Hello class, this is a continuation of trigonometry and the unit circle part 1. In the last video we saw that sine theta, cos theta and tan theta correspond to some values inside the unit circle. So for example, we said that sine theta means we draw an angle, we draw a unit circle, here it is. Then we measure the angle and make the right angle triangle, and then we measure the y value at that point. Likewise, cos theta means we draw the unit circle, this whole process here. We make the angle of theta, we draw the right angle triangle at that point, and measure the x value. This may seem a little bit abstract and doesn't quite make sense. So let's do some examples right here and right now. So when we calculate, say, sine 30 or cos 60 or even tan 45 is made in the calculator, its values, the values it is giving to you are corresponding to the values of the unit circle. So inside, it's a very simplified version of what's going on in the brain of the calculator. But essentially what it's doing very quickly is when we type in sine 30, the calculator quickly draws up a unit circle. It measures sine 30 degrees from the initial, we're going to make a 30-degree angle. That's about 45. 30 degrees looks to be about here, I guess. It's very hard for me to actually measure. And then from that point, we make a perpendicular height. And that there is our unit circle. Let me erase just these parts here. That there is 30 degrees. Now remember, this is a unit circle, which means we have a length of 1 on the hypotenuse. And now we said that sine 30 is the measurement of the y, the opposite of this angle. From the looks of this, well, remember this is 1 and that's a length of 1. This y value from my drawing looks about 0.5. That's about 0.5. That's about halfway. So this y value here looks to be about 0.5. So I'm making an estimation here that sine of 30 is actually 0.5. So the calculator is going to do the exact same thing that I've done, but super fast. So sine of 30, 0.5. Cos of 60. So when we type this into the calculator, it's doing at a very, very fast rate. It draws up a unit circle. It makes an angle of 60. So let's do that now. So here's my initial. It's my initial side. Here's my terminal side. We're going to make an angle of about 60. That's about 45. I'm going to take a guess that it looks to be about there. Okay. And then from there, let me erase some of these we don't need. From there, we make a perpendicular height, like so. That is our right angle triangle with 60 degrees and a radius or a hypotenuse of 1. Cos of 60 is the adjacent side from when we do this long process. So what is the length of the adjacent side? This one here. That to me looks about half again. That looks to be about a half on the x-axis. So I'm saying that cos of 60 is equal to 0.5. Let's take a look here. Cos of 60, about 0.5. And when we do tan 45, once again, when you type this into the calculator, it does a very long, very quickly, sorry, unit circle. It draws a 45-degree angle like this. It draws that perpendicular height, and it makes that right angle triangle like so. So that is 45 degrees, radius of 1. Tan 45 means we're going to take this length and divide it by this length. So that length looks to be about, well, that's 0.5. 0.75 is about here. I'd say that's about, we'll just estimate it to be about 0.7. And this length here, that 0.5 is about here. Yeah, I'd say it looks about 0.7 as well. So tan of 45 is the opposite, 0.7 divided by 0.7, which is 1. If we do tan 45, now remember the calculator, tan 45, it does this very quickly. What we just did, it's 1. I hope you picked up that I picked these values because it's very easy to measure. But the difficulty is now, what happens if we have not so neat angles? So sine 77, when we type this into the calculator, the brain of the calculator draws up a unit circle, draws a 77-degree angle. It's about here. It draws the perpendicular height, makes the right angle triangle, and then it quickly measures the y value because that is opposite. That to me looks about close to 1. I'd say it's about 0.9 something. So sine 77, I'm estimating by doing this by hand, 0.9. So 10, oh sorry, not 10, sine of 77, 0.97. Very close. Let's try this again. Cos of 15. Type it into the calculator. The calculator does very quickly the following process. It draws up a unit circle, makes a 15-degree angle. It's about here, I'd say. Makes the 90-degree triangle. And then it measures the length of x. Again, looks very close to 1, so I'm going to take a guess that cos of 15 is equal to 0.99, I don't know. Cosine of 15, 0.96. I'm not even going to try tan of 88, but the process goes as follows. It draws up a unit circle, makes 88 degrees, very close to 90, like so. Draws up the right angle triangle. And then it takes this length and it divides it by this length. I'm not even going to bother try guess what that is. Let's just type it into our calculator. Tan of 88, 28.636. There we have it. So I hope that gave you a little bit of more insight of how the trigonometry relates to the unit circle and the values of the Cartesian plane. Hope to see you in the next video. Best of luck.